Now let's look at the factors which affect the rate of enzymatic action or enzyme action. The functional specificity of every enzyme is the consequence of its specific chemistry and configuration. Any factor that can alter the chemistry and shape of an enzyme can affect its rate of catalysis. Some of the important factors that can affect the rate of enzyme action are concentration of enzyme, concentration of substrate, temperature, and the pH of the medium. Number 1. Enzyme concentration. The rate of reaction depends directly on the amount of enzyme present at a specific time at unlimited substrate concentration. If the amount of enzyme is increased by twofold, the reaction rate is doubled. By increasing the enzyme molecules, an increase in the number of active sites take place. More active sites will convert the substrate molecules into products in the given period of time after a certain limit in concentration. The rate of reaction will no longer depend upon the increase. Number 2. Substrate concentration. At low concentration of substrate, the reaction rate is directly proportional to the substrate available. If the enzyme concentration is kept constant and the amount of substrate is increased, a point is reached when a further increase in the substrate does not increase the rate of reaction anymore. This is because at high substrate level, all the active sites of the enzyme are occupied and further increase in the substrate does not increase the reaction rate. Number 3. Temperature. The rate of enzyme controlled reaction may increase with the increase in temperature, but up to a certain limit only. All the enzymes can work at their maximum rate at a specific temperature, called as the optimum temperature. For the enzymes of the human body, 37 degrees Celsius is the optimum temperature. Heat provides activation energy and therefore chemical reactions are accelerated at high temperatures. Heat also supplies kinetic energy to the reacting molecules, causing them to move rapidly. Thus the reactants move more quickly and chances of their collision with each other are increased. However, further increase in heat energy also increases the vibration of atoms which make up the enzyme molecule. If the vibrations become too violent, globular structure essential for enzyme activity is lost and the enzyme is said to be denatured. Number 4. pH value. Every enzyme functions most effectively over a narrow range of pH known as the optimum pH, as shown in the table 4.1. A slight change in the pH can change the ionization of the amino acids at the active site. Moreover, it may affect the ionization of the substrates. Under these changed conditions, enzyme activity is either retarded or blocked completely. Extreme changes in pH cause the bonds enzyme to break, resulting in the enzyme denaturation. Optimum pH values of some enzymes are pepsin 2 pH, sucrase 4.5 pH, enterokinase 5.5 pH, salivary amylase 6.8 pH, catalase 7.6 pH, chymotrypsin 7 to 8 pH, pancreatic lipase 9 pH, and arginase is 9.7 pH.